I'm here with Stanley Black & Decker. I'm my name is Paul Turner, Vice President for what we call Industry 4 Applications and Analytics. So that's anything really associated with data and driving value from data. A little bit about the company. So we're the world's largest tools and storage company. We're about $15 billion in revenue at the moment, with a target to be $22 billion by 2022. 61,000 employees and 140 factories worldwide. And up until about 18 months ago, none of them were connected. So there is now a significant undertaking, Industry 4 program, funded by the CFO, to connect as many factories as quickly as possible, but then also to run up the maturity curve for Industry 4 as quickly as possible as well. So Stanley and Black & Decker sort of merged in 2010, but we have nearly, I think it's 40 sub-brands, some you may be aware of, some maybe not. And we're not just power tools makers or hand tools makers. We have a security division and an industrials division as well. So as I said, the program has been ongoing for just over 2 years now. The 2018, it was really just set up and prove, just do some innovation and sort of think about architecture and what that would look like. 2019, it was sort of getting stuck in, making some mistakes, making some successes for deploy, and now 2020, it's all about deployment and scale. So when we're looking at Industry 4 within Stanley Black & Decker, we've initially focused on 3 value streams. So initially, which is a foundational strategy, is to just connect the factories. Typically, our factories can have 100, 200 assets that need to be connected. And so that is just a foundational investment. The plants themselves aren't required to actually justify the ROI for that connectivity. We drive ROI through the applications we layer on top of that. So when we're talking about belief, that's the belief that's there. We have a value stream on automation, which doesn't fall under my umbrella. So cobots, robotics, robots, AGVs, etc. And then analytics, which is my stream. And within that, we've had a plethora of use cases, many different use cases, as we were innovating and trying to look what worked, what didn't. And then what we're doing now is, in order to scale, is really wrapping these use cases into five-ish focus areas. Asset health, what we call intelligent quality management, tool management, labor management, and schedule optimization. So what's one of the learnings that we've had on the Industry 4 program? Well, from listening to some of the presentations, this is starting to sound familiar now. It's about moving away from silos. So some Industry 4 initiatives are very much IT focused, or historically have been IT focused, and it's all about building the platform and investing large amounts of money in sort of cloud-based infrastructure. In isolation, that approach tends to struggle to connect directly to the value on the factory floor. There's the technology-led approach, where it's all about, we've got an AI solution, let's just apply it, which can often be a technology trying to find a problem to solve, which isn't necessarily the best way. And then there's the operations-led approach, where it's part of lean manufacturing. Operations are looking for pain points, and they're mapping that to technologies. All sounds great, and it is, but in isolation, that approach struggles to scale, and you end up doing lots of POCs, but you lose that scope for standardization. So the bullseye there is to try and bring that all together into a single organization. And so at Stanley, we've created a center of excellence that integrates closely with the plants. And we've actually brought the IT and OT team under one sort of group. As far as analytics is concerned, I said this earlier, everybody's a data scientist these days. And data science is one leg of the stool for analytics. But as was said earlier, without context and domain knowledge, you can often make mistakes just by throwing data at AI. I have an actual real example here where if you pose this to a pure data scientist, they may scratch their heads, but why would a plant prefer a model that's only 8% accurate compared to one that's 90% accurate? And it's a real example, and the reason is that this was a defect detection exercise. Most of the defects on this line were caused by simple single sensor issues. Okay. However, it was the 10% that weren't caused by single sensor issues that were the ones that would have value. And operators already got alarms on the 90% that were single sensor. So what they didn't want was an AI model that would just provide a duplicate alarm. What we really want is one that focuses on those ones that your traditional SPC or process monitoring solutions can't find. So sounds trivial, real example, but what I'm trying to say there is it's the combination of data science plus the contextualization and then mapping that to value. You need those three legs of the stool to drive success. Starting from scratch, as Stanley Black & Decker did, we didn't inherit a legacy of sort of MES systems and SCADA systems. This really was starting directly with the PLCs and the data locked away in there. We want to be up in the right-hand corner, of course, in the journey to get there, but starting off in the bottom-hand corner. So on the horizontal axis there, it's sort of the analytics maturity, going from descriptive to the sort of prescriptive and closed-loop type analytics. And then from individual assets right through to the enterprise analytics. So we want to do the whole thing and move quickly as possible, and sort of we're sort of dotting about this matrix in order to get the basics right, but then get to the end point as quickly as possible. And so we focused on enterprise analytics as one stream, but also around specifically analytics around individual assets and cells. And for that, our strategic partner for edge computing is Foghorn. Sastry Malady is here for Q&A later. And I'll talk a little bit about those applications. So as I said earlier, we're focused, in order to scale, we're focusing on these individual bundled applications. So we had energy management applications, predictive maintenance, we'd call things anomaly detection, scrap reduction use cases, a whole plethora of different use case names, and we decided to develop them into just these sort of four main categories, and then some that we're also working on. And for the edge computing, that's really around the asset health and the intelligent quality management. I have a video here of one of those use cases. So this is, actually, I don't know, can I run this from here? So most of you are probably aware that Stanley Black & Decker makes tapes. And this is where we are printing the measurements onto the tapes. And what we're using is a Foghorn-based vision AI system for detecting defects on the line. And these are high-speed lines that you'll see. You see the sort of speed that it's going at. And each of these images has to be grabbed, analyzed, and then run through the algorithm in order to figure out whether a defect has been spotted. And you can see there, I don't know if this will shine. You can just see in the bottom right corner there's some smudging there that the AI has detected. And so this allows operators to intervene by providing an alarm. But it's not all about just raising an alarm. This is an event-based system, and we've got an event-based approach to Industry 4. Most of the solutions are event-based. But just providing an alarm to an operator isn't necessarily going to solve the problem. Yes, they want insights, but it's not just about insights. It's about driving behavior. how do we drive behavior? How do we make the operators care about the information that we're giving them? And bringing the financials into the situation would certainly be one way of doing that, but also developing a system around how to drive behavior. For example, we're working with Foghorn on the asset health solution, where we're looking one aspect of asset health, which is energy management. And we look at the cost of producing, in terms of energy and utilities, of producing 1 million parts. And let's say, for argument's sake, that the sweet spot is less than $100 for 1 million parts, and then we detect if that's exceeded. But if it's exceeded, it might be $150 that we're operating at, and we need the operators to intervene. But if the operator's focused on just getting the 1 million parts out, how do we get them to care about the fact that they need to act on this? Because although it's only $50 for 1 million parts, there's 200 potential assets across 365 days a year. It adds up to substantial potential value if we create the behavior in operations in order to act. And so we're sort of working along this sort of detect, analyze / act, and optimize and learn process. We're not all the way through that yet. It's a developing approach. But we're starting off with, say, phase 1, where it's about alarming and escalating. But we're also working with certain partners in order to develop how we optimize and learn. And one thing that might be is when we do detect a defect or an asset health issue, that there's a digital fingerprint there. And then if you drive behavior in operators to respond to that, and you digitize that process flow as well, then you have information and knowledge in a system that can be directly linked to a digital fingerprint. And then in the future, if we've got a plant in, say, Japan, and an algorithm is detecting that there's an issue or an event, it can then map that digital fingerprint to maybe something that happened on a factory in the US, and then provide up those insights as well. So it's not all about closing the loop automatically. I know there's a lot of concern about closing the loop and just leaving the AI to control the process. But this is a sort of an alternative approach where you're actually using digital fingerprints to provide those insights and to drive value. Very briefly on what the architecture is like. This is an evolving architecture. It's by no means where we are now or where we'll end up, but it sort of gives you a flavor. So we have the edge analytics on an edge device. So say our strategic partner for that is Foghorn. And then we have a mechanism for then taking that data, putting it in a data lake, and then going up that curve for more enterprise level analytics. We actually have what we call our nerve center in Hartford in Connecticut, where we're pulling all this data from eventually all 140 factories, where we can actually have sort of a air traffic control for manufacturing, looking at data across the enterprise and have algorithms hunting down sub-performing assets. So that's the vision, but it all starts at the edge. And so the final slide, why on the edge? Why edge computing? Everybody talking about cloud and enterprise level analytics, but there's still a lot to be done at the cloud. Some applications aren't just best suited for performing on the edge. It's the only place. For asset health, one of our sensors is we monitor vibration. These can be millisecond sensors across 200 assets. That's a high velocity, high volume data set. And of course, the video streaming on those high-speed tapes, you can see why that lends itself to being performed on the edge, and so not everything is applicable for cloud-based computing. So I'm not sure if I was over my time, but that's my presentation done.